Alrighty, this is video notes for section 9.1. We're going to start off by going through some of the terms that you need to know about polynomials. So we start off with a monomial. A monomial can be a number, it can be a variable, or it can be the product of a number and one or more variables with whole number exponents. For example, 24 would be an example of a monomial that's just a number. Y would be an example of a monomial that's just a variable, and 4x squared times y is an example of the product or the multiplication of a number and one or more variables. Here we have x and y, and x has a positive whole number exponent of 2. Whole numbers mean positive numbers. They cannot be negative, they can't be fractions, and they can't be decimals. So go ahead and write your own example here in this next box of a monomial. Next we have a polynomial. A polynomial is a monomial or the sum of monomials. So for example, a polynomial that's just one monomial is x squared, or we can take the sum of monomials, we can add them together. So we can have 24 plus y plus 4xy. So here we have the monomial 24, the monomial y, and the monomial 4xy. Whenever we're talking about polynomials, we refer to each of these monomials as one term. So go ahead and write your own example of any polynomial that consists of monomials. A binomial is simply a polynomial with two terms. So, for example, we could have x squared plus 5. Our first term is x squared, our second term is 5. So go ahead and write an example of a binomial. And last we have a trinomial, which is simply a polynomial that has 3 terms. So, for example, we could have y squared plus 2y plus 6. Our first term is y squared, our second term is 2y, and our third term is 6. So go ahead and write your own example of a trinomial with 3 terms. Alright, we have a couple more definitions that we can use to describe a polynomial, or the pieces of a polynomial. So first we have the degree of a polynomial. The degree of a polynomial is just the greatest degree of its terms. Degree means the exponent, so the highest exponent in any of its terms. So if we have the polynomial 5x plus 2x squared plus 7, the highest degree or the highest exponent here is 2, so the degree of this polynomial is 2. The leading coefficient is the coefficient or number that is in front of the term that has the greatest degree. So in our example, the greatest degree was 2, and we have a 2 in front of x squared, so the leading coefficient equals 2. We can also write this polynomial in standard form. The standard form is just written so that the degree of each term decreases as we go from left to right. So in our example, we can rewrite it in standard form by starting with the term with the highest degree, so that is 2x squared. Our next highest degree is just a degree of 1, or just x, so we're going to do plus 5x, and then we're going to end with plus 7, since 7 does not have a variable with a degree, or you can think of it as a degree of 0. Let's look at these two examples and rewrite them in standard form. So on the first one, we have 3x squared plus 2 minus 5x to the 4th. Our highest degree here is 4. So we're going to start with our term negative 5 x to the fourth. Our next highest term is x squared. So our next term will be plus 3x squared, and then we'll end with plus 2. On number 2, we have 7 plus 8x. Our highest exponent, or our highest degree here, is a 1. 8x is the same as 8 times x to the first power. So we start with 8x. And then this 7 has a degree of 0. Remember, if you think 7 times x to the 0 is the same as 7 times 1, or just 7. So our answer is 8x plus 7. Now if you look here, if we rewrite our polynomials in standard form, our highest degree, or the degree of the polynomial, and the leading coefficient will always be found in the first term. Next, we're going to learn how to classify polynomials by their degree. First, we have a constant function, or a constant polynomial. In a constant polynomial, the highest degree is, this should be a 0. The highest degree is 0. Like we just said, if we have 7x to the 0, that's the same as 7 times 1, anything to the power 0 is 1, which is the same as 7. So a constant polynomial will look like just a number. So, for example, one constant polynomial could be the number 60. Go ahead and write your own example next. And we have a linear polynomial. A linear polynomial is one where the highest degree is equal to 1. So, for example, we could have 5x plus 6. Our highest degree here is x to the first power. So that is a linear polynomial. You should be very familiar with this. Go ahead and write your own example. A quadratic polynomial has the highest degree of 2. So for example, we could have x squared plus 3x plus 6. Here our highest degree is 2. Go ahead and write your own example here. A cubic function, or a cubic polynomial, like you may guess, has the highest degree of 3. So for example, we could have y to the third plus y. Notice they only have 2 terms here, but the number of terms doesn't matter. We're only looking for the highest degree, which in this case is 3. So go ahead and write your own example of a cubic. And last, we have quartic, which, as you may guess, has the highest degree of 4. So for example, you could have x to the fourth plus 7. Our highest degree here is 4. So go ahead and write your own example of a quartic, and then flip to the next page in your notes, and you will see, whoop, too far. You will see this chart where it says checkpoint. So this is what you will need to do for homework, and I'm going to go ahead and do the first one with you. We are just filling in this chart. So starting with the polynomial 1 plus 3x, first we need to put it in standard form. So we start with 3x, or 3x to the first, plus 1. State the degree. Our highest degree here is 1. Our leading coefficient in front of x to the first power is 3. We can identify this by the degree. Our highest degree is 1, so this is linear. And by the number of terms, we have 2 terms, so this is a binomial. So go ahead and fill in the rest of the chart for tomorrow, and we will check it in class.